Good morning and afternoon, everyone. Welcome to today's webinar, Operationalizing Predictive and ML Applications with MemSQL. My name is Alicia and I'll be your moderator today. Before we begin, there are a few housekeeping items I'd like to review. Today's webinar is being recorded and you are currently in a listen-only mode. You may submit any questions you have throughout the webinar via the Q&A or chat function in the lower right corner of your console. You can also follow us on Twitter at MemSQL or live tweet us during the webinar using hashtag MemSQLWebinar. We will address everyone's questions towards the end of today's presentation. After today's webinar, you will receive a follow-up email with a link to the recording and slides. If you wish to contact us, please send us an email to team@memsql. Let's begin today's presentation on operationalizing predictive and ML applications with MemSQL. With that said, I'd like to introduce our speaker, Eric Hansen. Eric is Principal Product Manager at MemSQL. He is responsible for query processing, extensibility, and geospatial feature areas. He is a PhD graduate of UC Berkeley, was an Air Force officer, a professor of computer science at the University of Florida, and a principal program manager and developer for SQL Server at Microsoft. Eric was a Hive committer for contributions to Stinger and is a technology expert on data warehousing, column stores, and vectorized query execution. Thank you for joining us today and welcome, Eric. You now have the floor.
Hi, can you hear me okay?
Yes, we can.
Okay, great. Thank you, Alicia. And so today I'm going to talk about operationalizing ML and AI with MemSQL. Next slide, please. So now I'd like to be on the slide that says MemSQL, the no limits database, slide 4. So I just wanted to give you a quick recap of MemSQL, a little overview of MemSQL for those of you who may not be familiar with the product before I launch into discussing how to operationalize ML and AI with MemSQL. So MemSQL is a cloud-native operational database that's built for speed and scale. So the 3 words to remember about MemSQL are speed, scale, and SQL. So MemSQL allows you to load data extremely fast, to query with very high concurrency and very quick response time. It's super scalable. It's because we allow you to scale out on either your in-data center equipment or cloud-based platforms. You can spread data across multiple nodes for extremely high performance and scalability at arbitrary scale. And that really differentiates us from established SQL database products. And we are based on SQL, so that all the familiarity you and your developers have with SQL, you can bring that to MemSQL to get up and running quicker. And it helps with integration with other tools as well. Slide 5, next slide, please. So just a very quick overview of how MemSQL fits into your architecture. MemSQL can integrate with your analytics systems. It's an excellent platform to build dashboard applications, real-time dashboards in particular. It's good for ad hoc queries. We'll talk about how you can do machine learning. You can integrate with all kinds of application software. We can ingest very fast from multiple different data sources using a streaming loader as well as a standard bulk loader or just application software that inserts data into MemSQL. We've got lots of different data types. We support all the basic structured built-in data types, and it runs everywhere. Anywhere you want to run it, MemSQL will run. So with that, let's move on to the next slide, slide 6. So let's talk about ML and AI with MemSQL. Slide 7, please. So artificial intelligence has the potential to create tremendous value across different sectors. You can see this graph from McKinsey Global Institute that shows the share of AI impact in total, the share of AI impact and total impact derived from analytics, and the potential value in billions of dollars. So, as most of you know, AI is of tremendous interest to these days to CIOs in many different industries. And MemSQL is a great database platform to integrate with your AI applications and to bring some AI and decision-making capabilities to the data that you store in your database. So let's look at slide 8, challenges delivering a real-time ML application. So some challenges to deliver a real-time machine learning application are, first, data exploration and preparation. Once you need to explore your data and prepare it, clean it, transform it, and so on before you build a machine learning model. Then you need to do algorithm selection, model training, and model refinement. And then once you've built your model, you need to assemble data for scoring, and then do your scoring, and then you iterate on that. You refine your model and maybe retrain. So if you flip to the next slide, slide 9, you see in the blue text, this is where MemSQL can help. MemSQL can help to do data exploration and preparation because MemSQL allows you to manage very large data sets very efficiently. You can load data very quickly. You can transform data in the database by selecting from one table into another, and filter and project and perform, do expression evaluations on different columns to prepare data in exactly the format you want, and then insert that into another table. Also, MemSQL is amazing at assembling data for scoring. It turns out that it's not so trivial to assemble all the properties of an object that you want to have in order to feed to your machine learning model to calculate a score. Some of those properties take a lot of time to compute. So MemSQL is being used in really innovative ways to compute real-time properties just prior to scoring, and in order to make sure that you're doing your machine learning predictions with the freshest data and the most appropriate features. And then MemSQL can allow certain types of scoring in the database using SQL, which I'll talk about. And then MemSQL is also useful for model monitoring. So you could, every time you, in your application, apply a machine learning model to score some data, you can record the outcome in an event table in your database, and then use SQL with MemSQL to, with very high performance, analyze the results you're getting from your model and see how successful it is, and learn whether or not you need to refine or retrain your model. Next, please. Slide 10. So MemSQL can drive improvement across the machine learning lifecycle. So this path of application of machine learning is familiar to many of you. You can see we go from 1 through 10, several steps. So the ones that are circled in bubbles are the ones where MemSQL can help. So you have to define your machine learning use case or use cases. That's something you do as an application developer, kind of separate from the data. But then you have to explore the data. And once you've done that, you select your algorithm. And then you need to do data pipeline and feature engineering. And MemSQL is very useful for both the data exploration part and the feature engineering portion. And then you need to present results in a way that provides value to stakeholders. MemSQL can help some there as a reporting tool. And then operationalize your model, that is, deploy it as part of your application that's doing the real-time scoring. And MemSQL can help there by doing some in-database scoring or by assembling the features you need to score quickly and efficiently with the freshest data to get the most meaningful score. And then you need to monitor your model. And and I discussed that a little bit already. You can use MemSQL to save the outcome of your scoring and go back and do real-time reporting against that. Next, please. Slide 11. So MemSQL lets you operationalize ML and AI with speed, scalability, SQL, and programmability. So it allows you to score data during streaming load with pipelines transforms, which I'll talk about in a second. MemSQL pipelines is a very popular feature that's part of MemSQL that allows you to point MemSQL at a data source like a file folder or a Kafka queue or an S3 bucket, and the system will just start loading data from that source. And you can intervene a transform there, which allows you to do some machine learning scoring as part of that, which I'll talk about more in a second. Also, you can score fast in the database with MemSQL using built-in vector functions, which I'll elaborate on a bit. And also, you can use compiled expressions and functions in SQL to do machine learning scoring if that's more appropriate for you. And also, because we support scale out and high performance parallel query execution, you can scale lots of records at once concurrently. You can score lots of records at once concurrently with SQL. And finally, I'm going to talk a little bit more about how to assemble up-to-date feature records to score with an external app on the freshest data and use MemSQL to get the data to score. Slide 12, please. So let's look at how MemSQL operationalizes ML applications. Slide 13. So one part of operationalizing AI and ML with MemSQL is integration of your data management tool with the tools you use to train your models. So MemSQL is a fantastic tool for training as a source for training data. We can support virtually all tools that can connect to MySQL because MemSQL speaks the same protocols as MySQL. So applications that connect to MySQL can connect to MemSQL as well. So tools you may be using like Pandas, NumPy, TensorFlow, R, scikit-learn, SAS, and so forth can be used with MemSQL. And in fact, SAS has a named connector for SAS Access, which is the standard data connectivity tool that is delivered with SAS. There's a named connector from SAS to MemSQL. Next, please. Slide 14. You can use bulk loading tools for real-time ingest into MemSQL. For example, you can load data in real time from Kafka. You can use CDC tools, change data capture tools to load data into MemSQL, like from Attunity. You can apply transforms, for example, using Spark, Informatica, Talend, etc., to your data, then load it into MemSQL. MemSQL is also an excellent tool for integrating with your data lakes, whether they're in HDFS or Amazon S3 or Azure Blob Store. MemSQL can load very effectively from all those sources. Also using MemSQL pipelines with transformations that can apply machine learning scoring during the load process. Slide 15, please. So as I've mentioned this a couple of times, how to use MemSQL pipelines for scoring on load. So let's elaborate on that a little bit. MemSQL pipelines, as I said, it's an automatic streaming loader that can load from your file system, from HDFS, Kafka, or S3. And so as new information or files arrive in these sources, once you've set up your pipeline, it just automatically loads directly from that source. The standard approach with pipelines is just to load the data, and the data can be stored in CSV format, and the files that are arriving or the messages that are arriving in Kafka can have one or more records in CSV format, and they're run through basically the same logic as our bulk loader, which is implemented using our load data command. But there's some additional capability that allows you to do transforms on that data with pipelines prior to loading in MemSQL. So you can use scripts like Python or other scripting languages, or executable programs to transform the files or messages in these data sources on the left before they're loaded into MemSQL. So a common use case for this is to compute a new score column using a machine learning model that you've trained previously to compute a new column to be brought in during loading. So this is useful when you need to use an external scoring code module or library or set of libraries in order to perform the scoring process, but you want all the new data records to have a score on them. Next slide, please, number 16. So here's an example of the syntax for creating a pipeline with a transform. In this case, it's a Python transform. So the create pipeline command in this case is being used to point at a Kafka queue, and you give it information about how to reference a specific Kafka queue there. And then there's the transform clause, and the transform in this case is a Python script, myexecutable.py, that comes from a tar.gz file. In this case, we're using a URL that is actually something hosted by us in this hypothetical example, but you could use a URL that points it to code that you created and saved. And then the table, into table T there, that notation just says that that's the target table. So basically we'll run the messages from Kafka through this transform, and it'll create the output of it will be in a CSV type format, and that will be run through our loading logic and inserted directly into that table T. So that's a way to apply scoring of just about any kind of logic as you're loading the data. Next, please. So now we should be on slide 17. So let's talk about implementing scoring with extensibility capability in MemSQL. MemSQL has a very rich extensibility capability. It supports user-defined functions, stored procedures, user-defined aggregate functions, and also arrays, records, and a rich set of control structures. So using this programmability capability, you could implement a model that you had trained with a tool. Perhaps the model was output in a PMML format or some other format. You could, by hand, translate that model into a user-defined function or stored procedure in MemSQL, and then apply that in the database. So the benefits are that you can combine this with other SQL logic like joins and filters and so forth. And you can use SQL compatible tools together with the machine learning model that you've created as a user-defined function, say. And also, the performance of this can be excellent because we compile user-defined functions and stored procedures to machine code, and we provide scale out and parallel query execution. So through a combination of that high performance compilation and ability to apply parallelism at any scale you need beyond the size of a single computer or host, you can get amazing performance and throughput on scoring with MemSQL. Slide 17, please. So here's a really simple example of, kind of the simplest example you might think of for machine learning. Maybe you're just using a regression model, like linear regression. And suppose that you've trained a model and you've got a simple regression line that you now want to use in an SQL query. You could basically create a user-defined function, F in this case, that encodes that that function that you've trained, and then using a simple select statement, you can apply the model to a column, say X, from a table T, and get your score. So this is kind of the simplest model, and you can use this concept on much more sophisticated models that could be produced by machine learning tools that you're using. Next slide, please, slide 19. So another really cool thing you can do with MemSQL is to do scoring using a notion of what are called vector embeddings. So deep neural networks have become very popular in the last few years for advanced AI and ML use cases. And a typical way to think about deep neural networks is that you've got some high dimensional object like a matrix, and you're using that high dimensional object as input to the machine learning training process. And that using whatever machine learning tool may be your favorite, you can, and lots of training data, you can create a deep neural network that will score objects with this high dimension. But one technique that's proved very useful to many people in applications like face matching or product photo similarity matching is to use what's called vector embeddings. So you take after you've trained the deep neural network, you take one of these high dimensional objects, like say a 256 by 256 matrix that represents a face image, and feed that into the bottom of the deep neural network, and out of a hidden layer sort of in the middle of the neural network, you can read out a vector, typically like a 1,000 to 4,000 element vector that is a lower dimensional object compared to the input data, but still encodes a lot of the semantics of that higher dimensional object. And now, once you've got that vector, you can use it to do vector similarity matching. So let's go to slide 20. So you can do vector similarity matching using cosine similarity or Euclidean distance metrics. And MemSQL has the ability to do cosine similarity or Euclidean distance on these floating point vectors in the database. So you can create like a table like features with an ID number to represent an object and a feature vector, which is say a binary 4096 column that actually will hold 1024 floating point numbers, 32-bit floating point numbers, and that's going to be used to hold the feature vector. So let's go to the next slide, 21. So MemSQL includes two built-in functions to do vector similarity matching for these use cases where you're using vector embeddings from deep neural networks. So one is dot product, and the other is Euclidean distance. And we have very fast implementations of these that are based on single instruction multiple data, or SIMD. It's a very fine-grained parallelism mechanism. So we can do millions of dot products of two 1,000 element vectors on a 4-core system in a fraction of a second based on this very fast SIMD implementation. And there are some helper functions as well. There's a JSON array pack function that can take a JSON array of floating point numbers and turn it into a packed binary array. And then there's a vector subtract function as well for if you want to do some arithmetic on vectors beforehand to prepare them for scoring with these dot product and Euclidean distance functions. 22, please. So here's an example of running a query that works with these feature vectors. So you can select, say, ID and dot product of your feature vector, and the dot product is taken against a constant vector, which is represented here as input, and that will be your score. And you do that from features where the dot product of the feature and the input vector is greater than, say, 0.9 to reduce the total data volume, because maybe you happen to know from your use case example that you're only going to compare about values that have a score above 0.9. And then you can order by score in descending order, so the highest ranked matches are on the top. So we have some users that are using MemSQL today to do face matching using exactly this technique. Next, please. Slide 23. So there are some pre-trained neural networks that are open source that are available. For example, VGG Face and FaceNet. They're deep neural networks that have been pre-trained on sets of millions of faces. And you can use these to implement a face matching application using MemSQL, and you don't even need to retrain them. You can, because they're sort of universal face recognizers because they're pre-trained. And as I said, you can match millions of images in a fraction of a second with a small MemSQL cluster using these vector similarity functions. Next slide, please. 24. Let's skip this one. Let's go to 25. So I want to talk about real-time feature retrieval for scoring in OLTP apps. This is an important use case. That's a fairly new use case that we've developed with some customers and prospects. And the way this works is when you're applying machine learning, you're scoring specific cases as part of an application process. But in order to do the scoring, you need to get all the features of the object you're trying to score before you do the scoring. And those features may be much more sophisticated than you might think at first. So, for example, consider a credit card fraud detection application. We might be doing an application where there's a 1-second budget from the time you swipe your credit card to approval of the credit card. And you want to do fraud detection within this 1-second period, along with any other data manipulation you need to do. Perhaps there's only a 50 millisecond budget to do the fraud detection, but you need a 70 value feature record in order to do the scoring. So there might be 70 properties of this feature vector that you're scoring. Now, where are these feature properties going to come from? Let's go to the next slide, slide 26. So in a credit OLTP application with scoring, machine learning, fraud detection scoring built in, a user request to say purchase something with their credit card is going to come into an OLTP application. That application will query an OLTP database in order to get ready to do the credit approval. But one thing we've seen customers build into their architecture is to use MemSQL as a real-time operational data store in order to extract the features they need for scoring. So let's go to the next slide, please. So actually, no, let's stay on this one. Stay on 26. So the OLTP application is going to query the OLTP database and MemSQL, which contains additional information that's to assist as part of the scoring process for fraud detection. Build a feature record that has, say, up to 70 properties, then pass that to an application server, the scoring service, to get the score, and then that score will help the OLTP application decide whether or not to approve the charge. So let's talk about what kind of queries might be necessary to run. Go to slide 27, please. So to create the feature record in real time, here's an example. Some of the properties that might be necessary for scoring. Has this customer transacted with the merchant before? The days since the last transaction with the merchant. Maximum amount ever transacted with a merchant in the last 180 days. Similarly, the minimum amount for the last 180 days. 180-day total merchant transaction amount. The number of the card present transaction count in the last 1, 7, and 30 days. the online transaction count in the last 1, 7, and 30 days, and up to 70 total features like this. So the old way of doing this was basically to run a nightly batch job to pre-compute these features and save it with every customer record in an operational data store. The new way is to run up to 70 queries to produce each of these features fully up to date and fresh on the latest data. And MemSQL enables this new way of doing things. And the benefits are that this allows new features like transactions in the last 2 hours, which were not even feasible before, and also allows all the features to be fresh on the freshest data. So the result can be a higher quality machine learning result and improved fraud detection. And if you just improve by a fraction of a percent the number of fraud cases you can predict, you can save and make a lot of money and easily pay for the value of MemSQL many times over. So next, please, slide 28. So it's just, this next slide is additional resources. So MemSQL, so there's some information that is available on the web. You can look at documentation about the vector functions I told you about. Also, there's a really neat Google crash course on machine learning that talks about vector embeddings that can be used in combination with these built-in vector functions in MemSQL to do scoring. And finally, there's a MemSQL blog on face matching that talks about how we've enabled some of our customers to do face matching with the MemSQL database. And at this point, we'll take questions. Slide 29, please.
Thanks for your presentation, Eric. We're running a little behind on time, so let's dive right into some of the questions that we received. Does MemSQL integrate with Spark ML, and is it used for any customers?
Yes, so we have some customers that are using Spark ML as they prepare their data prior to loading with MemSQL, and they're computing machine learning scores on new records and adding them as additional fields to records prior to loading with MemSQL pipelines.
Great. What is the best way to integrate the ML model? Is it to develop REST API and call it from the pipeline transform script, or to build it inside the transform script and call it as a function?
So I think that it really depends on the use case. I think that if it's easier for you to call a REST API from the executable that's doing the pipelines transforms and it's efficient enough, then that may be fine. If you really need to do high performance loading where you're loading, many, tens of thousands of records like per second, then in that case, you probably want to take all the logic and build it into an executable that you use as part of the pipelines transform, because that'll be faster than maybe doing a remote procedure call to a RESTful service.
Okay. And can MemSQL use or integrate with an existing PMML model?
So MemSQL can't use PMML models directly, but you can translate PML models into stored procedures or user-defined functions in MemSQL. So you can either write a translator, or if you're not doing it too often, you can translate by hand. So the PMML models are in XML, and you could write a program that basically, in a very straightforward way, walks that XML and produces expressions in a user-defined function that you could use.
Okay. And we have time for one last question. Which of the following architectures is better? One pipeline write to stored procedure and the procedure inserts into 5 tables, or 5 pipelines for each table? And this question has a note. The pipeline is extracting the JSON, which contains 5 fields, and each one will be inserted into 1 table.
I think it sounds like in that use case, it makes sense to use pipelines and the new pipelines to stored procedures capability that we've introduced in, I believe it was in MemSQL 6.7, to take that data and parse it apart and do updates to multiple tables in the stored procedure that's part of the pipelines to stored procedures arrangement. But of course, it's hard to tell. And with a question like that, it might take more analysis of the use case to give the best solution.
Okay, great. Thanks. Thank you, everyone, for all of the questions. Unfortunately, that's all the time we have for today. For those of you with questions we did not get a chance to address, we will follow up with you directly. I want to thank Eric and each of you for attending today. Just a reminder, we'll be sending you a follow-up email with a link to today's recording and slides. If you have any questions in the future, you can send an email to team@memsql.com. We invite you to learn more about MemSQL at memsql.com or give us a try for free at memsql.com/product. Again, thank you for participating and have a great remainder of the day.